The universe is held together by a phantom. Dark matter, a substance that neither emits nor reflects light, acts as the invisible scaffolding of our cosmos. Without its gravitational pull, the Milky Way would fly apart, and the vast clusters of galaxies we observe today would have never formed. Despite its critical role, dark matter remains one of the greatest mysteries in modern science, accounting for roughly 85% of all matter in the known universe while remaining completely undetectable by conventional means. For decades, the leading scientific theory suggested that dark matter was composed of trillions of subatomic particles. Researchers built massive underground detectors and high-energy particle colliders to catch a glimpse of these tiny building blocks, yet these efforts have yielded nothing but silence. This persistent lack of evidence is now pushing theoretical physics toward a more radical and daring perspective. Instead of a vast ocean of microscopic dust, dark matter might consist of a few, incredibly massive ghost objects drifting through the interstellar void. These proposed entities are not stars made of atoms, but rather exotic structures known as boson stars. These are macroscopic quantum states formed from particles so light that they behave more like waves than solid matter. In the early stages of the universe, these quantum waves may have collapsed into stable, self-bound structures the size of stars. Another even more bizarre candidate is the Q-ball, a stable blob of energy formed from concentrated quantum fields. While these sound like concepts from science fiction, they are supported by rigorous mathematical models and supersymmetric theories. Since these objects are invisible, scientists cannot look for them directly. Instead, they look for the way their mass warps the fabric of space and time. According to Einstein's theories, a massive object passing in front of a distant star will bend the light traveling from that star. This creates a subtle, telltale wobble or a brief shift in the star's apparent position and brightness. This phenomenon is known as gravitational lensing, and it is the primary tool currently used to hunt for these invisible giants. The Gaia Space Telescope, originally designed to map the positions and movements of over 1 billion stars in our galaxy, has unexpectedly become the ultimate weapon in this hunt. By tracking the trajectories of stars with extreme precision, Gaia can detect even the slightest deviation in their paths. If thousands of these dark objects are floating through the Milky Way, Gaia's massive database likely already contains the evidence of their passage. Every piece of data that fails to find a signal is still a victory for science, as it narrows down the possibilities and forces our theories closer to the ultimate truth. If astronomers eventually capture the precise moment a star moves out of turn, it will not be a mere coincidence. It will be the first time the universe reveals its deepest, most hidden architecture, proving that the giants moving in the dark have been there all along.